Today we're going to be taking a look at this Gibson Skylark GA-5T. The owner complaint was that first off, it doesn't have a fuse cap, so it doesn't have a fuse, so he really has no way of even plugging it in and playing it. Obviously it's missing the handle. I'm going to get a fuse cap for it, put the fuse in, bring it up slowly, open it up, also see if it has any leaky capacitors. If the filter caps are original, they're potentially going to need to be replaced. So if that sounds interesting, please stick around. Okay, so I got the Gibson Skylark running. It's only at 70 volts wall voltage. This is measuring the DC voltage on the filter capacitors. And as you can tell, there is a very loud hum. And if we take a little look at the actual filter capacitor package, you can see there's some visible damage there, like some kind of moisture or leakage. Earlier I plugged my phone into the speaker, the 10-inch speaker that is part of the Gibson amp, and it sounded really good to me. And so far I've been kind of just testing speakers by plugging my phone into them and playing some music that I like. And so it sounded good. The speaker sounded like it's got plenty of bass, even for a small speaker. This is actually two capacitors. You can see it's 20 plus 20 microfarads, and the red is positive, black is negative. What that means is from one red wire to the black is one 20 microfarad capacitor, and then from the other red wire to the black is the other capacitor, also 20 microfarads. This one I'm going to replace with two separate 20 microfarad capacitors. This little ring that is holding it up, I'm going to take the ring off, and you can see it's attached with just a bolt and nut. I'm going to use a terminal strip. I also went through and measured all of the resistors, and I didn't measure every single one. I measured quite a few, probably like half of them, and all of them were super close to what they should be. None of them look physically bad. None of them like have any black spots or any like swollen bumps or anything like that. So I think that they're all probably good. Alright, let's do a final walkthrough of what I've done to this amp electronically. We're pretty much done. I changed the two 20 microfarad filter capacitors for 22 microfarad 500 volt FNTs. And then over here, our bias capacitor, our bypass capacitor for the power tubes, was 20 microfarads at 25 volts, I believe. Let's see. Yeah, 20 at 25. Replace that with 22 at 50. Over here we have another 20 microfarad electrolytic for another filter stage, filter capacitor. That was 20 at 300 volts. The new one is 22 at 500 volts. Over here we have our bypass capacitor for the input stage. This one was 20 microfarads at 6 volts. And the new one is 22 at 50. Okay, and finally, this is the only mod that I did to the amp. There was, coming out of the first stage of the preamp, there was this 0.005 capacitor going into the infamous Sprague couplet that a lot of these Gibson amps have from the 60s, going into the input of the volume knob, and then from there it goes back to the second stage. So I took those two components out and I replaced that part of the signal path with just a single 0.01 capacitor. The reason I did this is because these Sprague couplets have this effect where they really just take out all of the body of the signal, and what you're left with is this just strange nasal sound. So I experimented with a few different values for that position, and I thought that the 0.01 sounded the best. So that's what I went with. Okay, I'd like to go through and show how all of these parts test, and explain sort of why I took each one out and replaced it. So first we have the first two filter capacitors, both 20 microfarads in one package. And the first thing I noticed really when I pulled the amp out actually was looking at this. You can see there's some physical leakage there. Comes out to 289 nanofarads, 140 ohms of ESR, and 28% voltage loss. So that is clearly not good. This should be 20 microfarads, of course, and those top two numbers should be around, 1%, 1 ohm or so for a new capacitor. So let's go ahead and test the other capacitor in this package. 18 nanofarads, 15% loss, pretty much useless in this circuit. So that component was obviously bad, so we replaced that with the two F&T capacitors on the terminal strip. Next, we have the final filter capacitor, another 20 microfarad at 300 volts DC. Okay, so this one's supposed to be 20 microfarads. It shows 25. That's fine. 1.2 ohms, that's very low. 1.6% voltage loss. This one could have lasted for a long time, potentially. There's a couple of reasons I decided to take it out. The biggest reason is because, okay, so on the negative end, there's some white goop there. There's some kind of white goop there. And on the positive end, there's some sort of reddish goop. And I don't think that that's leakage from inside the capacitor. Correct me if I'm wrong, but that doesn't look like leakage to me. But if you look closely at the positive end, you can see that, for one thing, it's sort of cracking. This rubber gasket is sort of cracking around the center. And then also underneath that red goop, you can see there's a little bit of a bulge. And right there. So this one is probably pretty close to being on its way out. Okay, next we have this 20 microfarad, 25 volt small electrolytic capacitor. This was the bypass cap hooked to the cathode of the output tubes. No unknown or damaged part. Once I got the filter capacitors changed and kind of slowly brought it up, it made a guitar signal, but it made a strange, nasal, awful guitar signal with not a lot of body or bass. This brought some of the bass back, some of the body back when I replaced this with a working capacitor. Another 20 microfarad, this time only 6 volts. This was the bypass capacitor for the first stage, the input stage on that first 6EU7. 98.46 microfarads, 4.9 ohms ESR, 9% voltage loss. So this is clearly not what it's supposed to be. It's almost 100 microfarads. It's only supposed to be 20. And also the ESR and voltage loss are higher than I would like them to be as well. So this one got replaced. Okay, so I was looking through the amp and I realized that I did something that I don't like when other people do, so I need to come in here and fix it. These two capacitors, when I put them in so that you can't see the label, and whenever I open an amp and I see that, it bugs me, and if someone sees this, they're going to think two things. Number one, they're not going to know what value these are, and number two, they're going to curse the name of the last person who was in here forever. Because it's very inconvenient, and maybe no one will ever open this amp again after me, but I know that it's wrong, and I'm going to fix it. Just to be on the safe side, since I'm using this pretty big soldering gun some of the times, I like to just put a little alligator clip next to the component as a heatsink. Okay, now that's much better. Next time someone opens this up, they'll immediately see those values. I'll be able to sleep at night because I know that it was done right. So let this be a cautionary tale and a reminder to myself. If you do something that you don't think is right, go back in and make it right. Also, do it right the first time. Okay, let's take a look at some date codes throughout the amp here. Let's start with the power switch. That's Centralab. You can see the little CRL diamond. And also 134 we know is Centralab. And what's the next two digits? 64, 1964, and then 05, that's the 5th week of 1964. Can we see any date code on the volume knob? I don't know if it's going to be visible from here. Yeah, I think it's on the bottom side down there. Let's take a look at the tone knob. Tone potentiometer. Can't see a date code on that either. Here's the filter capacitors. Date code 6408. That's 1964, 8th week, from Astron Corporation. Here is another filter capacitor, also Astron. And where's the date code on this guy? Oh, once again, 6408. So also 8th week of 1964. We have 1064. This might not be a date code. I'm not sure on this one, but I interpret that as the 10th week of 1964, sort of backwards from what you usually see. This one also says 1064, so we know it's not a part number because these are two different parts. So I'm not 100% sure, but I'm guessing that's the date code, the 10th week of 1964. Let me know if you know if this is the date code or if I'm wrong here, if it means something else. What we've seen from the switch and those few capacitors that we just looked at, that puts this amp pretty firmly in sort of the beginning of 1964. Here on the output transformer we have another 1964. That's 6405, 5th week of 1964. On the power transformer we have 996. I'm not sure what manufacturer that is, but then we have 6349. So that's the 49th week of 1963. So right at the end of 1963. And let's see if we can find any date codes on these tubes. They're all original as far as I can tell. Here we go. That is 6413, so 13th week of 1964. And then over here, matching 6413, so those are the two power tubes. Those are 6 BQ5s. Here's the 6X4 rectifier, 6409. So 9th week of 1964. The tubes, the output transformer, and the power transformer also confirm our earlier date of early 1964. We have one last thing to check, and that would be the speaker. Let's see if we can find a code on it. I don't see a code anywhere on here. In fact, I think it might be underneath that Gibson sticker. But that's okay. We've seen every part in the amp point to 1964, so we're going to call this a 1964 Gibson amp. When I got this amp someone had previously cut the speaker wires, and they just had them twisted on to the old speaker wires here. But I'm going to take these little pieces off and solder them back on like they should be. It's usually a good idea to take anything, just a little piece of paper, kind of block the speaker cone with it so that you give it just a little extra protection. There we go. Now all that's left to do is put the back panel back on. And this back panel didn't have these 4 wood screws when I got it, and I couldn't find any good wood screws laying around that would fit, so I'll be leaving those off. And I'll just be putting it back on the way it was, with these 2 machine screws going through here. And on the other side there'll be a couple of nuts that hold it secure. And the chassis can only slide out through the front, so this pretty much does the trick. This board keeps it from sliding out from the front, and the chassis itself keeps the board from coming off the back, so... Okay, one last thing, these wires are kind of up against one of the tubes here, so I'm just going to kind of move those further out of the way. Down here looks pretty good. Yeah, now they're away from that 60U7 now, they're kind of butting up against it. loudness and the speed of the tremolo. There's no tone control and there's no depth control, so the tone is basically all the way up. So you'll want to use your tone knob on your guitar, probably. Otherwise it's going to be very bright. And then also there's no depth control for the tremolo, so the tremolo is basically all the way on at all times, and you can just control the speed. So here's kind of the slowest speed. Alright, so there you have it. That's the Gibson Skylark GA-5T, 1963. If I were to find one of these amps out in the wild for a couple $100s, I would definitely pick it up. It sounds great. It's a little on the bright side, but it definitely has like that sort of sweetness that a lot of vintage amps have. Also, I should point out that it does not have a handle on it. The owner of it didn't even really want me to put a handle on it, but I talked him into it, and then I bought a handle, and the largest one that I could find online was still too short from side to side. So we decided to just go without the handle. If you like this video and you found it in any way entertaining or useful, please consider subscribing, because I will be making more videos like this in the future. If you think I did something that you would do differently, leave a comment. Or if you just want to have a discussion about this amp or any part of the video, leave a comment and I'll be sure to reply to you. Thanks for watching.